What is the double angle trigonometric formula? Now let us say that we have a sine alpha plus a beta. The answer to this trigonometric expression is actually given by the addition formula. By the way, we have actually uploaded a video on that stuff, so feel free to check that out on the channel. And I've also linked it in the description section below, so you could go check that out. Now, if we wanted to express this in addition formula, that is going to be equal to sine alpha cos beta plus cos alpha sine beta. This is what you're going to have. Now, in this case, we do not really want to work with two different angles because, as you know, alpha is going to be a different angle from beta. In this case, we actually want to use just a single angle. So let us say that you have something like alpha and you added it to itself. That means you actually have two of these angles. Now, if I got alpha plus another alpha, that should clearly give me 2 alpha. So this should be 2 alpha. Now, I'm just going to use the formula above and work it for the double angle. So first I know that stuff should be sine alpha cos alpha. And here we're going to have a cos alpha sine alpha. Now notice that this is actually similar to these other stuff. So in that case, we're just going to add them together. And we're going to have a 2 sine alpha cos alpha. And therefore, we can say that the double angle, this represents the double. And so this is actually equal to 2 sine alpha cos alpha. This is going to be the first double angle formula. So I'm just going to place it above here. So we got sine 2 alpha, and that is equal to 2 sine alpha cos alpha. Now next up, let us work the ones for cosine. So let us say that you have cosine alpha plus a beta. Well, that is going to give. Now in this case, we know that they should give us cos alpha cos a beta. That will be minus sine alpha sine beta. Now in this case, we're going to use alpha plus another alpha. So we should have a cos alpha plus another alpha. They should give us cos alpha minus sine alpha sine alpha. So that is what we got. Now in this case, we have cos alpha multiplied by itself. And so that should give us a cos squared alpha. Here we're going to have a sine squared alpha. So that is what we got. Now we know this is actually cos 2 alpha. That gives us cos squared alpha. Need to rewrite it. Minus sine squared alpha. Now we already know from the trigonometric identities that if you have a 1, 1 could actually be equal to cos squared alpha plus sine squared alpha. Now the first thing I'm going to do, I would actually make cos squared alpha to be the subject of the formula from this equation. So how I need to do that is take sine squared alpha away from this side and bring it to this other side. So in doing that, I'm going to have a 1 minus sine squared alpha, and that will be equal to cos squared alpha. So what that means is I actually do have a cos squared alpha to be equal to 1 minus sine squared alpha. So I need to rewrite this. This should actually be squared right there. So in this case, remember, we actually had a cos 2 alpha, and that is equal to cos squared alpha minus sine squared alpha. Now in this case, from the trigonometric identities, I actually do have a 1 minus sine squared alpha. So what I'm going to do is plug in 1 minus sine squared alpha as cos squared alpha from this equation. So in that case, I'm going to have cos 2 alpha. That will be equal to 1 minus sine squared alpha. This will be minus sine squared alpha. Now minus sine squared alpha minus another sine squared alpha, that will give us a minus 2. So we have a 1 minus 2 sine squared alpha. This is what we got. So cos 2 alpha is equal to this. So I think I just need to write it here. That is a cos 2 alpha. That will be equal to 1 minus 2 sine squared alpha. Now notice that from this equation, we can actually also make the sine squared alpha as a substituted part of that equation, because we also know from trigonometric identities that you got cosine squared alpha plus sine squared alpha. So I could make sine squared alpha as the subject. So if I wanted to do that, this is what I'm going to have. I would have 1 minus cos squared alpha. That is equal to sine squared alpha. And so in this case, I'm going to take sine squared alpha and replace it with 1 minus cos squared alpha. So what is that going to give? Now that is going to give me cos squared, well, cos 2 alpha rather. And in this case, I'm just going to have a cos squared alpha minus sine squared alpha. Now sine squared alpha is exactly what you see here. So we just need to replace that with it. In this case, I'm going to have a 1 minus cos squared alpha. So that is what we got. I think I can wipe these out now. So we need to take a -1 and follow that bracket with it. So in this case, we're going to have a cos squared alpha minus a 1. And here we have a -1 multiplied by another minus. So we should have a positive there. This is going to be plus cos squared alpha. Now here we have cos squared alpha plus another cos squared. So that should give us a 2 cos squared alpha minus a 1. So in that case, we also know that cos 2 alpha is equal to 2 cos squared alpha minus a 1. So I need to write it here also. We got 2 cos squared alpha minus a 1. So this would actually be the second formula. Now from here, we can actually find something else. Now let us look at the first one. We have that cos 2 alpha that is equal to 1 minus 2 sine alpha in it. 2 sine squared alpha rather. Now I could make sine squared alpha as a subject from here. So how to do that? I need to take this to this other side. Then I'm going to take this to the other side. So this is going to give me 2 sine squared alpha. This will be equal to 1 minus cos 2 alpha. Now I want to take this 2 away from here. Take note, 2 is actually the coefficient of this function. This is actually the squared form. So this number is different from this one. So we're going to take this away from here. Now in order to do that, we need to divide it through by 2. So doing that, we're going to have a sine squared alpha that will be equal to 1 minus cos 2 alpha. That will be divided by 2. Now we need to find what sine alpha is going to be. Now we already know this means sine alpha all squared. and that is equal to this. So we need to take the squared form of it away from there. Now how can we do that? How can we take the squared away from this place? Now basically we need to take the square root of both sides. If we did that, that is going to cause this part to get eliminated. And so that is going to take the square to this other side. So let us take the square root of both sides. Doing that, we're going to have this. And on this side, we're going to have this. So this is a 1 minus cos 2 alpha divided. So I need to write it better. That is divided by 2. Now we know that from here, this 2 is going to cancel these out. So we should actually have a sine alpha. So sine alpha is equal to the square root of a 1 minus a cos 2 alpha divided by 2. So this is another way in which you could find the sine of an angle. Now let me give you an example. Let us say that you were required to find sine 15 degrees. Now if we took this as the alpha, then we need to find the cosine form of the double angle of 15. That is going to be 2 alpha. Now 2 alpha, that means 2 multiplied by 15, which is going to give us a 30. So obviously we need to find the cosine of the 30. So let us look at it. Now this will be equal to the square root of a 1 minus cos of 2 multiplied by 15. This is divided by 2. So this is going to be a 1 minus cos 30. This is divided by 2. Now what is cos 30? Cos 30, that is going to be equal to root 3 divided by 2. So we need to plug that back into the equation. That will be 1 minus root 3 divided by 2. This is divided by 2. Now from the laws of sorts, we could actually take up this square root and split it into 2, so that we're going to have the numerator as a 1 minus root 3 divided by 2, and this will be divided by root 2. So that is actually what we got. Now next thing I'm going to do is I would actually take this root 2 and use it as the stuff that would rationalize this expression. So let us say we are multiplying this whole stuff by a 1. Now 1, I'm actually going to make that 1 to be root 2 divided by root 2. So this will be a 1 minus a root 3 divided by 2 divided by root 2 multiplied by root 2 divided by a root 2. Now we know that root 2 multiplied by root 2, that is going to give us a 2. So we got a 2 here. Now above here, we actually have a square root, which is multiplied with 2 multiplied by 1 minus a root 3 divided by 2. Now we need to work this off. What is going to be 1 minus root 3 divided by 2? So let us see what that is going to give. Now first, we know that 1 is the same thing as 2 divided by 2. So instead of a 1, I'm actually going to use a 2 divided by 2 there. So this will be minus root 3 divided by 2. Now obviously this should give us a 2. If you take a 2 and divided it into this, that would give you a 1. So that is a 1. That is a 1 multiplied by 2. That gives you a 1. And here you have a minus 2 divided into 2. That is still going to give us a 1. So I think I made a mistake here. This should be a 2. And here we're going to have a 3. So this is what you have. So I need to write it out. Where am I going to write it now? think I'm gonna take these out now. So here you have a 2 multiplied by 2 minus root 3, all divided by 2. And this is all divided by 2. Now we know that this is going to cancel these out. So I'm going to take these out now. So this would give us root 2 minus root 3. This will be divided by 2. So this is actually going to be the answer to root 15. Now obviously there is also another way that you could do this, but this is one way to do it. So from here we see that sine alpha is equal to 1 minus cos 2 alpha divided by 2. That will be the square root of that whole form. Now we could also do it another way. We could take this equation and find something new. So let us say that we have a cos 2 alpha, and we know that is going to be equal to cos, well, that is 2 cos squared alpha minus a 1. So I need to rewrite that. Now what I'm going to do is I would actually take this 1 to the other side. So that will be a 1 plus a cos 2 alpha. That is equal to 2 cos 2 alpha. I think I need to rewrite this. 2 cos squared alpha rather. I'm taking this away from that side. That will give me a 1 plus a cos 2 alpha. This will be divided by 2. So we're going to have a cos squared alpha. Now in order to get just the cos alpha, I need to take the square root of both sides. So let us write it here. Cos alpha is going to be equal to the square root of 1 plus cos 2 alpha divided by 2. So that is what you got. So that is basically how to find the cosine or the sine of a single angle, basically. Now, how about the tangent of a single angle? How are we going to find it? So first off, we know that tan, if you got tan alpha, that should be equal to sine alpha divided by cos alpha. So we need to use what sine alpha is and what cos alpha is. That will lead us to tan alpha. So we know that sine alpha is equal to the square root of a 1 minus cos 2 alpha. I think I need to rewrite that. This is divided by 2. We have this stuff divided by the square root of 1 plus cos 2 alpha, all divided by 2. Now we know that this is going to be written as this. This is tan alpha. That will be equal to, I think I'm going to split this up now. This is a 1 minus, say, cos 2 alpha. So this is divided by root 2. Okay, I think I need to take this side. So this will be 1 minus cos 2 alpha divided by root 2. This stuff, this is actually what it's going to look like. So that is actually correct. Now we need to divide it because that is the meaning of this stuff. And here we're going to have a 1 plus cos 2 alpha. That will be divided by root 2. So from here, we need to flip this and change it to multiplication. Now in order to do that, we're going to have a 1 minus cos 2 alpha divided by root 2. This will be multiplied by that stuff. Now this would actually get flipped. So I should have a root 2 on top. And below here, I'm going to have this stuff. That will be 1 plus cos 2 alpha. Now I know that this is going to cancel this. So these two stuff, they're actually going to come together. And so I should actually have something like this. This will be a 1 minus a cos 2 alpha. And this will be divided by the square root of a 1 plus a cos 2 alpha. That is what we're going to have. Now I could well take this square root sign and forge it, or merge it rather, with this other one. And so that should leave us with something like this. We're going to have this. This is a 1 minus the cos 2 alpha divided by 1 plus cos 2 alpha. And so this is actually the other form of the stuff that you have. That is for tangent. These other ones are actually for the sine and the cosine. Hopefully you understand the idea. Now notice that we have not actually found what tan 2 alpha is going to look like. So but by now you already know how to find the cosine, the sine, and the tangent of a single angle. So I'm just going to wipe these ones out and try to find out what tan 2 alpha is going to look like. So I know that tan alpha plus a beta from the first video where we actually had the derivation for the addition formula, we had that this should actually be a tan alpha plus a tan beta, and that should be 1 minus tan alpha tan beta. And we're going to use this form to work tan alpha plus a tan alpha. Now first we know that tan alpha plus an alpha, that obviously is going to be tan 2 alpha. So let us see what that is going to look like. Now we know this should be a tan alpha plus another tan alpha. And here we're going to have a 1 minus a tan alpha multiplied by itself. So if you got a tan alpha added to another tan alpha, what is that going to give? And that should obviously give us a 2 tan alpha. This will be divided by 1 minus tan alpha multiplied by itself. That should give us a tan squared. So that is going to be tan squared alpha. So that pretty much is it. That is how to find tan 2 alpha. So I need to write it here. So tan 2 alpha, that is going to be 2 tan alpha divided by 1 minus a tan squared alpha. So that is what you got. So that will be the answer to the question. So let us try another example. Let us say that you had a tan 120 degrees. What is going to be the answer to this question if you were required to use the double angle formula? Now we know that tan 120, that is actually tan 2 multiplied by 60 degrees in it. So I'm just going to work with 60. This is going to stand for the alpha. Now notice that here we got to work tan 60 degree. And tan 60 degrees, that is actually going to be a root 3 in it. Because if you had a tan 0, that should be equal to 0. If you got a tan 30, that should be a root 3 divided by 3. And tan 45 is going to give you a 1. So tan 60 is going to be equal to root 3. So that is what we got. So if I wanted to work that, tan 120 degrees, that is going to be equal to tan 2 multiplied by 60. So I just got a 2 multiplied by tan 60 right here. And this will be divided by 1 minus tan 60 all squared. Because that is basically what this means. If you have a tan squared alpha, that should be tan alpha all squared. So that is going to be basically it. Now on this side, I know this is going to give us a root 3. So I'm going to have a root 3 there. And here I'm actually going to have a 1 minus a root 3 all squared. Now I know that if I had a root 3 all squared, the root is going to cancel with the power of the 2. And so that basically leaves us with a 3. In other words, you could also have it as this. We have a root 3 multiplied by itself. This should obviously give us a root now. And root now is also going to be equal to a 3. So that is the same thing. We got a 3 as the answer for the root 3 squared. So on these other side, we're going to have a 2 root 3 divided by 1 minus a 3. Now we know that 1 minus a 3 should give us a negative. That is going to give us a negative 2. So we have a 2 root 3 minus a 2. And here we obviously know that this 2 is going to cancel with the 1 below. So that should give us a root 3 divided by negative 1. Now if you got a root 3 divided by negative 1, what is that going to give you? So that obviously should be a negative root 3. So the answer is going to be a negative root 3. That is basically how to work this. If you want to solve questions using the double angle formula, you just need to know these 3 rules. Now they actually work. And from here, you could also form the single angle rule or formula, just as we did previously. Feel free to rewind the video and go check it out. So that is basically it for this video. Now you can see that you know how to derive all the formulas which were called the double angle formula, as well as the single angle.